Identity operators. These operators are used to compare the addresses of two objects. These operators are used to compare the addresses of two objects. Identity operators are is and is not. Comparing the contents, go for comparison operators. Comparing the content. Comparing the addresses, identity operators. Comparing the addresses of two objects. For example, yes. So in the last session, we have seen these examples, right? Example 1. So address of X and Y, same or different? Address of X and Y, same or different? Different addresses, right? Because the contents are different. X is Y. X address is equal to Y address. True or false? False, right? X equal to Y? False. A equal to 10, B equal to 10. Address of A and address of B, same, right? Contents are same. A is B, true. A address is equal to B address is true. A content is equal to B content, true, right? A is not B, false, right? Okay. Now, if you observe this example 1 and example 2 that we have discussed in the last class, here both are returning false, right? If you observe, both are returning false. X is Y, X equal to Y. Both are returning false. X address is equal to Y address and X content equal to Y content. Okay. Is there any situation? Is there any situation that observe here? One returning true, other returning. Here both are returning true. Here both are returning false. Is there any situation where one returns true, other returns false? Means is operator returning true and this one returns true, other returns false. But here both are false. Here both are true. Is there any way where one is returning true, the other is returning false? Any example where is operator, if it returns true, this equal to should returns false. But here in these examples, both returning false, both returning true. Yes. Observe this example 3. X equal to 10, 20, 30, 40, 50. Y equal to 10, 20, 30, 40, 50, right? X is 10 to 50 and y equal to 10 to 50, right? X is 10, okay. If their content, okay, now try to say both are list type. Print X comma address of X, and Y comma address of Y. Now try to comment on this. Address of X and Y, same or different? Address of X and Y, same or different? Contents, X content, Y content, both are same, right? If the contents are same, only one object, only one address to be given, right? So here one object or two objects? One or two? Observe here, A equal to 10, B equal to 10. A content, B content, same. So one object or two objects? one object. Address is one. Here in this case, address of X and Y, as per our discussion, only one object need to be created, right? Only one object. The address of X and Y should be same, right? But here X and Y address will be different. X address and Y address are going to be different addresses. X is Y. Run module. X is Y is what? False. See there X address and Y address, different addresses, right? So in the case of collection data types, even though the contents are same, the addresses are different, multiple objects are in most of the collections, right? Understand this. In the case of fundamental data types, okay, content same, only one object. In the case of collection types, why? Because now they are looking same, right? Now both X and Y are same, right? In the case of collection, so print X is Y, X double equal to Y, both are one returning true. X equal to Y is true. X is Y is false. X equal to Y is true, but address are different. Now print what is the value of X of 1? X of 1 value 20, right? X of 0 is 10, X of 1 is 20. Can I modify to 25? Yes, right? Previously it was 20, now it was changed to 25. Observe, X of 0 was 20. This is X of 0, X of 1, indexing, forward index. X of 1 value is 20, but I am assigning 25 now. Now it changed to 25. Now do you think both X and Y are same? No, right? See this X 10 25, but this is 10 20, right? Both are different, right? That's why different addresses it gives, because now they look same, but later you can modify the elements. X of 0 you can modify, X of 1, X of 2, all this you can modify them, right? Understood? Any query in this? Addresses. So this is identity operators, means to compare the addresses in most of the collections. Even though the same content, the address is going to be different. Multiple objects gets created. Okay. Next operator, membership operator. The name itself saying whether it's a element is a member or not. Membership operators. These operators are used. Yes. Whether an element is present or not. Whether an element is present or not. These operators are used to check whether an element is present or not. whether an element is present or not, right? Okay. Membership operators are two types. In, not in, right? In operator and not in. Membership operator in and not in. X equal to list 10, 20, 30, 40, 50, right? Okay. Try to answer 10 in X. 10 in X, right? True or false? True, right? Yes. Print 70. Not in X. Right? Hmm? True, right? Membership operators. Let the question complete, right? 70 not in X. True. Print. Now you say 70 in X. False, right? Run module. True, true, false. True, true, false, right? Now from here on, from every week, I'll discuss about one ID. Every week I'll be discussing about one ID, right? You just execute all this code on that IDs. In real time, we use IDs, integrated development environments, not this ideally, right? So I'll be discussing one by one ID. This week I'll show you one ID, right? You can execute your code, Python code on that ID. Next week, one more ID I'll say. Means depending upon different environments, different IDs. For data science, one ID will be used. For big data, one other ID will be used. For Python web applications creations, one ID will be used. So I'm going to give you the knowledge on all the IDs. So you can work with any IDs. You can execute the code on IDs, right? How to download and how to install them. Okay. Fine. Tomorrow, just I'll show you ID on PyCharm ID. Mostly used ID for Python, PyCharm. Fine. So PyCharm, again, there are two IDs in there. One is free, one is licensed. Means one is community, one is professional. Community edition, professional edition. Professional, I'll discuss while creating web applications with Python. Community, I'll be discussing tomorrow. So you can execute your code on that. You can execute in this and check. For developing code, you use this. But that also, you can just have knowledge on how to execute your code on different IDs. Fine. And it's similar, okay. Similarly, if I take a string like this, y equal to Hyderabad, y equal to Hyderabad, right? For example, print h in x, h in y, sorry, h in y. True, right? The character h is present in y or not? True. HTML, basic HTML, creating web page, no? For creating a web page, right? How to include a text with different colors, fonts, tables, images, hyperlinks, forms, frames, buttons, all those. How means a typical web page. If you open any web page, right, you can see images in it, videos in it. Okay, tables, forms, buttons, all those things, right? Okay. H in Y, print A, not Y. P, P in Y, P in Y is fonts. Print not in Y. Character P, not in Y. True, false, true, right? True, okay. So this true, false, and true. Yes. Where exactly this in operator and not in operator can be useful is, for example, X equal to list of employees. Otherwise, employees equal to EMPS. Employee names are like this. Fine. Think that you have got some 100 names, a list of 100 names. Check whether a particular name is available in the list or not. For example, John in EMPS. In the employees list, do you see John? John in EMPS? False. James? James in EMPS. Print. Kohli not in EMPS. True, right? So in this way, whether a particular employee is present or not in the list, or whether it is not present, okay, it returns true or false. False, true, true, right? Okay. Next, what is the next kind of operator? So bitwise operator, the name itself saying working with the bits. Bitwise operators, bitwise operators, right? Working with the bits. Bitwise operators, nothing but working with bits. One byte equal to how many bits? 8 bits. One byte equal to 8 bits, right? So before we go with bitwise operators, you need to understand how to convert a decimal number to binary number, decimal to binary conversion, and binary number to decimal. How will you convert a decimal to binary, binary to decimal? Because to understand that bitwise operators, right, you need to understand this decimal to binary, binary to decimal. Now try to answer. See first, how to convert a decimal to binary? Observe this. First, binary to decimal is sending. If any binary value is there, how will you get the decimal equivalent of it? For example, there is a binary number 1011. Try to say the decimal value of it. Anyone? What is the decimal value for this? Right?
Sir, it is 11, sir.
Pardon, what is that? 1 second. Yeah, what is the value?
11. 11.
11. The answer is 11, right? How come 11? Yes, sir. 2 power 0, 2 power 1, 2 square, 2 cube. 1 into 2 power 0, 1 into 2 power 1, 0 into 2 square, 1 into 2 cube. Add all this. 1 into 2 cube, what is that? 8. 0 into 2 square, 1 into 2, 1 into 2 power 0. 1. 2 power 0 means 1, right? So what is the output? 11. Yes. Try to solve this. 1 0 1 0 1 0. What is the equivalent? Decimal equivalent. Everyone try to do this. Two. What is that? 40? 41 will be wrong. Okay. This is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. We need to add all this. We need to add all this, right? Add all this. 2 power 5 means 32. 0 into 2 power 4, 0. 1 into 2 cube, 8. 0 into 2 square, 2 plus 0. 42, right? Yes. Next, one last. 1 0 1 1 0 1 1. What is the value? Binary value, right? $91. 91.
Yes, sir. 91 is correct.
91 is correct. Okay. Two power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. 2 power 6. 2 power 6 means 64 plus 0 plus 16 plus 8 plus 0 plus 2 plus 1. 64 plus 16, 80, 88, 90, 91, right? How to convert a binary to decimal? Binary to decimal. Next, decimal value, if it is given, what is the binary value? 1 second. So this is binary to decimal. Next, if decimal value is given, I want the binary equivalent for it. Decimal to binary, right? For example, 17. I want the binary value of 17. What is it? Binary value for the 17. Decimal value is there. Binary value will be what? 10. 17 means 2 for 2 power 4 you keep 1. For 2 power 0 you keep 1. For okay 2 power 4 you keep 1. For 2 cube you keep 0. For 2 square. For 2 power 1. 2 power 0 keep 1. 1 0 0 1 you got. 2 power 4 means what? 16 plus 1. 16 means 2 power 4. 1 means 2 power. But how will you do this, right? Just the easiest way is, how will you find a binary value for a decimal value? Just 17 is there, right? 17. Previously, in the previous example, you are multiplying this 1 with 2 power 0, 1 with 2 power 1. In this, you divide 17 with 2. 2 8s are 16. 1 is the remainder, right? 2 4s are 8. 0 is the remainder. 2 2s are 4. 0 is the remainder. 2 1s. 0 is the remainder. Now see the reminders. 1 0 0 0 1. Nothing but your number, right? 1 0 0 0 1. Take the reminders. 1 0 0 0 1. Yes, this will be the easiest way, right? Divide that number by 2. Whatever reminders you are getting, right? 1 0 0 1. Okay, similarly, you work for it. 29. Say for 29, send me that value. What is that? 11101. Everyone got the same? 11101. 11101. Observe 29 you divide by 2. Observe 29 you divide by 2. 2 14s 28. 1 will be the remainder, right? 2 7s 14. 0 is the remainder. 2 3s 1 is the remainder. 2 1s 1 1 1 0 1. 1 1 1 0 1. Right? Understanding? Yes. If you want, you can check this whether it is 29 or not. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 16 plus 8 plus 4 plus 0 plus 1. 16 plus 8, 24 plus 4, 28 plus 1, 29, right? Right. So this is the binary equivalent for 29. This is for, okay, 17, right? Fine. Next for 53, try to say for 53. What is the binary equivalent for 53? Double 1 0 1 1 0. Answer. This is wrong. Double 1 0. Double 1 0 1 0 1. Just divide this 53 by 2. 2, 26. 1 remainder. 2 13s. 0 remainder. 2 6. 1 remainder. 2 3s. 0 remainder. 2 1s. 1 1 0 1 0 1 1 1 0 1 0 1. Understood, right? So how to convert a decimal to binary, binary to decimal? Understood, right? You can work with your own examples, right? For your practice, if you want to see more examples. Okay. Now coming to this binary, what is that? Bitwise operators, right? Bitwise. So this is the binary equivalent for 53. For binary to decimal, decimal to binary. Okay. Bitwise operators, observe this. Bitwise operators, first observe this. Bitwise operators are used to perform operations on bits. The see bitwise operators, see this works only on integers. Bitwise operators works only on integers. For floats, other things, it's not going to work. The integers are first converted into binary, and then operations are performed on bit by bit. If you convert a decimal to binary, you will get bits, right? For operations, whatever operations we perform, right? Perform on bit by bit. Hence the name bitwise operators. The result, whatever you get, right? The result, final result is again converted to decimal format. Bitwise operators works only on integers. What are the various bitwise operators? Bitwise AND you got, bitwise OR, bitwise exclusive OR, and left shift, right shift. Left shift and right shift. Bitwise AND or see X and Y, X or Y, X exclusive or Y, X left shift, right shift. 1 byte equal to 8 bits, right? So up to here you can make a note. We'll discuss more on these different types of bitwise operators fast. Fine. Finished. So Converting decimal to binary, binary to decimal. Okay. Okay. Converting a decimal to binary and binary to decimal, right? Now, observe this A and B are there. A value 1, B value 1. A and B value 1. If both are ones, it returns 1. 1 and 1 returns 1. If in the case of end, if any one is 0, 0. 1, 0, 0 only. 0 and 1, 0. Both are zeros, 0. In the case of R, A or B, right? If both are ones, it returns 1. If anyone also, if anyone is 1, it returns 1. 0, 1, 1, 0, 0. But what is this exclusive or difference between AR and A exclusive or means the input should be different. In the case of exclusive or, if the inputs are same 1, 1, it returns 0. If the inputs are same 0, 0, it returns 0. If the inputs are same, it returns 0. The input should be different. If it is 1 is 1, other is 0, then it returns 1. 0 and 1, 0, 1. Understanding? If the different inputs 1 or 0, 0 or 1. But if the inputs are same, 0 it returns. If both are ones, if both are zeros, it returns zeros. Remaining case, it returns 1. Take this fast. Understood, right? A, B, A and B, A R B, A exclusive R B. Observe this bitwise and everyone. Bitwise end. First you observe returns 1 if both bits are 1, else it returns 0. For example, A value is 10, B value is 7. If you want to perform A and B value, what is A and B value? What is A and B value? File, new file. Here I am writing the program code. Later you can take this program. Program illustrating bitwise. Don't take this program now. Finally, later when I complete the total program, you can take it. A value is 10, right? A is 10. B is 7. What is A and B value, right? What is the value of A and B? Okay. What is A and B value means? 2 you got. How you got 2? A value is 10, B value is 10. What is A and B value means? It is saying 2. How you got this 2 means? First convert that A equal to 10 into binary. 1 0 1 0. B equal to 7 also convert to binary. What is A? 1 0 1 0. What is B? 0 triple 1. I want A and B. A and B. Now see, we are going to perform operations on bits. 0 and 1. What is the value? 0. 1 and 1. 1. 0 and 1. 0. 1 and 0. 0. What is that output? The A and B value is 0010. This final binary value again convert into decimal value. What is output 2? Now you got how you got that 2? Take this fast now. Okay, next is bitwise OR, right? Observe this. Later we can write this program. What is A and B value is 2 you got. Find P, A or B. What is that value for R? A or B? What is the output you get for A or B? Run module. 15. How you got this 15 means? Observe. Returns 1 if any one of the bit is 1 or if both the bits are 1. If any one of the bit is 1 or both the bits are 1, it returns 1, right? Otherwise it returns 0. A value 1 0. B value 7. What is the binary equivalent? 1 0 1 0 triple 1. A or B? A is 1 0 1 0. B is 0 triple 1. 0 or 1? 1. 1 or 1? 1. 0 or 1? 1 or 0? This is the result, right? This result converted to decimal. What is the value you got? 15. Now you got how you got 15? A or B. Take this fast. Next is exclusive OR. What is the value of exclusive OR? You got 13. You got. Observe this. Exclusive OR returns 1 if any one of the bit is 1 and the other is 0. If it returns 1 if one bit is 1, other is 0, else returns false. It returns 0 if both the bits are 1 or if both the bits are 0. A value, B value. Convert into binary. This is binary equivalent of both. 0 or 1, 1. 1 or 1, 0. Both are 0 or 1, 1. 1 or 0, 1. This is the value. Means 13, right? You got understood how you got 13? Okay. Next is bitwise left shift. Bitwise left shift. Observe carefully before you write. Clearly, I have represented here. Everyone, try to look. A equal to 10. Binary equivalent is this. A value is 10. Binary equivalent is this, right? A left shift 2 means A left shift 2 means the leftmost 2 bits. These 2 bits are there, right? A left shift 2 means leftmost 2 bits. Remove the 2 bits from the left side and add 2 zeros at the right side. Okay, first after removing 2 bits from the left side. So if I remove this leftmost 2 bits, if left shift 3 means 3 bits, remove the 3 zeros. After removing the 2 bits, what is the output? In this way you will see. Understand? 8, totally 8 should be there. Here 6 only. The leftmost 2 got removed because left shift 2. Now adding 2 zeros at the right side. Right side 2 zeros got added, right? What is a equivalent value? 40. What is A left shift to value? 40. Observe this once. Print whether you got 40 or not, you check. A left shift to whether you are getting 40 or not, you check. You got 40 or not? How you got this 40 means what we have discussed, right? Once again, observe. A value is 10. Binary equivalent. A left shift to 2 means leftmost 2 bits you remove. After removing leftmost 2 bits, this is the output. Leftmost, these 2 bits got, this is your value. To this one, add 2 zeros at the right side. This is the value you got. Take this fast, left shift everywhere. See, generally, A value 10 means what is that binary value? 1 0 1 0. Actually, 1 byte equal to 8 bits, right? Remaining all you should keep it as zeros. A value 10, okay. So this is the binary, but be remaining all zeros in it. A left shift 2 means okay, left shift 2 means leftmost 2 bits you remove. After removing, you will get like this manner, right? And adding this, adding 2 zeros at the right side. What is the value? 40. 2 power 5 and 2 cube. 32 plus 8, 40. Here, okay. If 0 1 is there, assume 0 1 is there. Remove that leftmost 2 bits. Remove this leftmost 2 bits. And here what I should add? 2 zeros only I need to add. Add zeros only. Remove that bits and add zeros only. Don't say here 0 1 removed. So 0 1 should be added there. No. Zeros only you add.
The value falls in that first two bits.
That's what. Here 0 1 is there. Remove that leftmost and add 2 zeros at the right side. It doesn't mean that here you have removed 0 1, you need to add 0 1. How many you are removing? How many those many zeros you keep there? For example, A value 10, right? Everyone try to answer. 0 0 0 0 1 0 1 0. This is that 10. A right shift 2, you say. Rightmost 2 bits you remove. Rightmost 2 bits you remove. You will get the output in this way. And add 2 zeros at the left. What is the value? 2. Check it once whether you got 2 or not. Print A right shift 2. Sorry. Run module. 2 you got? Yes. Right shift. Take this everyone. After removing 2 bits from the right side, this is that value. And adding 2 zeros at the left side. The final output is 2, right? Okay. Finished? Left shift and right shift. Understood everyone? Left shift and right shift. Okay. Fine. Now, okay. Now observe this. Write this program now. A value 10, B value 7. A and B, A R B, A exclusive or A left shift, right shift. These are the values. How you got these values? We have discussed, right? Okay. So this is related to bitwise operators and operators in Python. Arithmetic comparison, logical assignment, identity, membership, and bitwise operators, right? So next I'll be discussing about flow control statements in Python. Flow control statements in Python means this flow control statements, it's little different as compared with other programming languages. We have got concept of indentation, blocks and indentation. So in tomorrow's session, I'll be discussing about flow control statements. So I'll stop here for today. Meet you tomorrow, right?
Thank you, sir.